We're going to be talking about parametric equations. I'm sure you absolutely remember this from pre-calculus. And so I'm going to review real quick and then show you some things with calculus for it. There's a lot of formulas in this section. There's a lot less of how do you use it and why do you use it, and more of just here's a formula, memorize it, and do it. So hopefully I can help you with that. First of all, let me show you an example of a parametric equation. Parametric equations, there are two of them. And what it is it gives you a third variable. T usually stands for time, and X and Y might have to do with like height and depth, or it creates three variables in a problem. It might be weight and height and time. So it shows you how all things are happening in related to time. And I can show you tomorrow how you can put this in the calculator. But for now, I want you to graph these parametric equations, and I want you to be able to solve them and make an equation that says y equals something like you're used to. So first of all, you're going to make a table for t and for x and for y. And you're just going to pick some t values. Usually you want to pick some negatives, and you want to pick 0, and you want to pick some positives. So unless it's just a weird kind of problem, I'm just going to pick like from -2 to 2. And then I'm going to plug those values in for t. And then I'm also going to plug those values in for y. And then we're just going to graph those points. You don't graph the t because this is the x and y coordinate plane, so you just graph the x's and the y's. -5, 3. -3, 2. -1, 1. 1, 0. And 3, -1. Basically, it gives us this line. And so you would graph the line. But the trick here is that you have to put an arrow on the line, because as I start from the negative, it goes that way. It's possible that when I draw the line that I would have started over on the right and then it would have went up, and in that case your arrow would have went the other way. So it's very important for you to draw the arrows on these problems, because the arrow indicate what direction you're going in relation to time. So that's the first part you're going to do, is you're going to come up with the t values, figure out the x's and y's, and graph it. Next thing you're going to do is you're going to solve the equation for y. And see, this is already solved for y, but what we're going to do is we're going to solve this equation for t, plug it in for t, and then you'll have an equation in terms of x and y. So if I solve that first one for t, I add 1 on both sides, and then I divide by 2. And then it told me that y was 1 minus t, so I'm going to take that and put it in the place of t. You can leave it like that if you want to. If you did solve it completely, it would be 1 minus x over 2 minus 1/2, which is -x/2 plus 1/2. And that makes sense because this is saying that the slope is 1/2, the y-intercept's 1/2, or the slope's -1/2. And if you go back and look, it does look like the y-intercept might be 1/2, and it's going down 1 and over 2 every time. So and that's how you can sort of check to see if you did it right. It won't always be lines, but it was on this one. So here's another example. X equals square root of t, and y equals t plus 1. This time, when I make my t's and my x's and my y's, I'm not going to put any negative values for t, because I know that I can't take the square root of any negatives. So I'm going to start it at 0. And I want to find things I can take the square root of easily, so I might just do like 0, 1, 4, maybe 9. And then plug those values in for x and for t. And for x, to get x and to get y. Then I graph them. Just be sure that you recognize like where you start, because we're going to have to put that arrow on it. And notice it's not exactly a line, it's more like a shape, like a parabola shape, and the arrow's going that way. Because I started at 0, 1, and then I went up to those other points. To solve for the equation here, it's pretty easy because this one already solved for x equals. So I just plug that. Well, I have to solve it completely, but square both sides. And then I'm going to plug the x squared in for t into the y equation. You get y equals x squared plus 1. That does sort of look like y equals x squared plus 1. But the final answer just really, it's x is greater than or equal to 0. So, but since you can't put negatives in for that time. Okay, here's your first try problem. You're going to have a couple more at the end. And on this one, I'm going to tell you that I only want you to go from -2 to 3, so pick values from -2 to 3 when you're picking your t's. So I want you to graph it and write the equation. Now, there's some other things that I can show you about parametric equations. There's another one that's kind of strange with circles, and I'll show you that tomorrow. But you can also do derivatives with these things, but it's just the point of knowing the formulas and how to set them up and everything. So there's 3 formulas you need to know. First of all, if I want to find the slope or if I want to find the derivative of a parametric equation, then I'm looking for dy dx. That's the notation for slope. And what you do is you find the derivative of the y part of the parametric equation, and then you find the derivative of the x part of the differential equation, whenever you're looking at the equation, and you just divide them. So if y was 2x squared minus 4, that wouldn't be an x, it would be a t, sorry. And if x was 4t, then the derivative would be the derivative of the y with respect to t, and then the derivative of x with respect to t, and you would just get t. And that kind of makes sense. The second one is finding the second derivative, and it's a little bit more in depth. I'm going to show you where it comes from, but in the end you just need to know the formula. That's how you write the notation for the second derivative. I don't know why they put the 2's where they do, but they do. What this is saying is find the derivative of the dy dx. Now, if I kind of rewrite this a little bit, I know that dy dx means find the derivative of y with respect to t and find the derivative of x with respect to t. So I have that. And then I can rewrite this just a little bit. I'm going to put this dy and that dx together. And then I'm going to put this d and the dt together. And when I do that, if I just rewrite it, that gives me d dt. And then dy dx over dx dt. This is the actual formula that you need to know right here. What this is saying is find the derivative of whatever you got when you found the first derivative. Found the derivative of that. It's with respect to t. It'll have t's in it, and you'll get rid of that. And then you divide it by whatever you got when you found the derivative of x. So let's go back to that first equation, this one here. If I'm going to find the second derivative, the formula says find the derivative of whatever you got. So find the derivative of the t. The derivative of t is 1. And then the derivative that you had originally of just the x, that goes on bottom. I'll do another example of that in just a second. So there's 2 formulas. The third formula you need to know is arc length, and I know you're really excited about this one as well. Previously, you learned that there was an arc length formula whenever you just had like y equals an equation. and it was the integral from a to b of the square root of 1 plus the derivative of x squared. And the problem is here the derivative is a little different. Now I can rewrite, again I'm going to show you where that comes from, and I'll show you where the formula is in just a second. But this is the same as saying dy dx squared. And then what you can do is you can multiply by, oh, I haven't rewritten it yet, I'm sorry. This is the square root of 1 plus, okay, dy dx in terms of parametric equations is dy dt squared over dx dt squared. And then I can simplify, like I can multiply by this to get rid of it being on the bottom. So I don't have to rewrite it all. When I multiply the blue times the 1, you get the blue. When I multiply the blue times that whole thing that's divided, you get that. And if I multiply by it, I also have to flip it and take it outside of the square so that I'm not changing anything. I'm going to try to write that over so you can see it a little bit better. So it looks kind of like that. The dx's go away. And so your actual formula is the integral from a to b of square root of dx dt squared plus dy dt squared dt, which means your answers are going to have t's in them. So if I go back to that original equation, 2t squared minus 4 and 4t, if I find the arc length here, then I'm going to do the integral, and I would have to tell you, maybe it told you to go from 2 to 4, I don't know. It would have to tell you that. And then you would do the square root of each of those derivatives squared. So the derivative of 2t squared minus 4 would be 4t, and then you square it. The derivative of the 4t is 4, and then you square it, and then you would plug that in the calculator. So the formula is actually a pretty easy one. It's just another formula to memorize. Couple more things that I need to show you. So that's the 3 formulas. I also may give you some questions related to tangent lines and to horizontals, but I think I'll do that as I show you some more examples. So we're back to examples now. Okay, let's say you have x equals 2 square root of t and y equals 3t squared minus 2t. And I think this is actually example 3. I want to find dy dx, and I want to find the second derivative as well. So dy dx means that I find the derivative of the y with respect to t, and then I find the derivative of x with respect to t. Okay, we're talking about derivatives here. So this is where you do 1/2 times 2 and then t and then subtract the power. So it would be t to the negative 1/2. Now, there are times when simplifying this makes it easier. This is one of those times. Because whenever I come down here to find the second derivative, I'm going to have to find the derivative of this. And if you'll simplify, it does make it a little bit easier. So you don't always have to do that. It just depends on the problem. On this one, you're going to do 6t over t to the negative 1/2 minus 2 over t to the negative 1/2. And then just rewriting, subtracting exponents, 1 minus 1/2, that's 6t to the 1/2 minus 2t to the 1/2 because you can bring it up. And this should have been a 3 because you're doing 1 minus -1/2. This is okay for the answer, but you're going to need this answer when I find the second derivative. So the second derivative, the formula says that you find the derivative of what you got. So I need to find the derivative of that. That goes on top. 6 times 3/2, that would be 9t to the 1/2 minus, and then bring the 1/2 times the 2, so it'd be minus t to the -1/2. And then you divide it by the derivative of the x. So you find the derivative of whatever you got, and then you divide it by the derivative of x. The derivative of x here would have been 1/2 times 2, and then t to the negative, so it's t to the -1/2. Again, that answer is okay, but if you simplify it the way I simplified the derivative above, you would end up with 9t minus 1, which would, on multiple choice, those would be the answers that you would see. Okay. Another question it might ask you is it might give you an x value and a y value and tell you to find the tangent line. At t equals 3 pi over 4. So what I know about a tangent line is that I need a point and I need a slope. To get the point, I need an x and a y value. So I'm going to take that 3 pi over 4 and plug it in for t in each of those. You can use your calculator or you can use math. But the x value is 2 squared of 2 and the y is 3 squared of 2 over 2. If you used your calculator and got decimals, that's okay too. You also need your slope, and your slope is the dy dx, which in this case you just find the derivative of the top, which is 3 cosine of t, and then you find the derivative of the x, which would be -12 sine of 3t. And I realize I wrote that wrong, which it doesn't make a big difference, except it does change these values. So I'm going to change that back, I'm sorry, to 4 cosine of t, which means the derivative here on the bottom would be -4 sine of t. It doesn't really change this right here. It makes that correct now. So we have an m, we have an x, and we have a y. To get our final m, though, we're going to have to plug in the 3 pi over 4 in for t to see what we get for the slope. I think when you plug it in, you get 3/4. And then to write the equation of the tangent line, you would have y equals mx plus b. Use your calculator to figure out what that b is going to be. So there's another mistake, I'm sorry. This is supposed to be a negative. But if you use your calculator to find the b there, then you get 4.242 for the b. So your equation would be y equals 3/4 x plus 4.242. Or that could be a 3 there. Now, just so I can show you another example, let's continue to use this same x and y, and I want to show you how you would find the second derivative. We already figured out that dy dx was 3 cosine of t over -4 sine of t. Your formula over here says you find the derivative of what you got and you divide by that by the derivative of x. Well, the derivative of x, we already know, is -4 sine of t. But to get the top answer, you're going to have to do the quotient rule here, because you've got to do the derivative of that. So I'm going to do the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And it's going to look strange, but that's what's going to happen. It's going to be 12 sine squared of t plus 12 cosine squared of t over 16 sine squared of t. And there's a rule about sines and cosines. If you have sine squared of something plus cosine squared of something, that equals 1. And because these are both 12, that means you have a 12 on top. So technically that goes on top up here. And if you simplify that, it would be 12 over 16, and then you divide by -4, which is -3 over 16, and then I think there's going to be a sine cubed on the bottom whenever you multiply it out. So that's the final answer there. Alright, I think the last kind of problem I want to show you, well, there's two. What example was this? This was example 4, so we're on example 5. Let's say that you have x equals t squared plus t and y equals t squared minus 3t plus 5. And it wants to know where the horizontal points of tangency are. Well, remember that horizontal points of tangency is where the derivative equals 0. So you first have to find the derivative, which means you find the derivative of the y, and you find the derivative of the x, and you divide them. Well, horizontal tangents would be where the top equals 0. So you would get 2 minus 3 equals 0, which means 2t equals 3, which means t is 3/2. But whenever you find the point here, it has to be in terms of x's and y's. So then you would take that 3/2 and you would plug it in for t into both of them, and you would get 15/4 and 11/4. So that's for horizontal. Now, it possibly could say vertical. If it said vertical, then you would set the bottom equal to 0. You get t is -1/2, and then you plug that -1/2 in up there for t's. So you would get -1/4 and 27/4. Okay, I promise this is the last one. Let's say that we want to find the arc length. And we know that x is t squared plus 1. We know that y is 4t cubed minus 1. And we're going from 0 to 1. Your formula says that you do the integral from 0 to 1, square root, each derivative squared. 2t squared, and then 12t squared squared. And if you put that in the calculator, I don't have what the final answer is, but you could put that in the calculator to find the final answer. Alright, here's your last try problems. Your equations are going to be x equals 3t squared and y equals 4t cubed minus 2t squared. So the second try problem is to find dy dx. The third one is to find the second derivative. The fourth one is to find the tangent line at t equals 1. And the fifth one is to find out where the horizontal tangents are. I didn't do an arc length one, but you do need to know how to do that also.